Hello, all, and welcome to the Edge AI Blueprint. We're so excited to have you here today. My name is Ed Doran. I'm the Vice President of the Edge AI Foundation, and we have an incredible conversation lined up for you. Today, we're going to be talking about VillageOS, generative AI for sustainable and autonomous housing. And with our guest today, we have an incredible guest lined up as well. Our good friend and friend of the foundation, James Ehrlich, who is a director of compassionate sustainability at Stanford University, an entrepreneur in residence, and has an incredible storied past, both as an academic and an entrepreneur. James will be joining us in a moment, but for now, let's get ready for the blueprint. James, welcome.
Wonderful. So great to be here. Thank you.
Now, James, we're so excited you could make time for us today. As I mentioned, you are a director at Stanford and the entrepreneur in residence, but when I look over your resume, you have the kind of past we all wish we had. I see a serial entrepreneur, a founder, a co-author, an advisor to such institutions as NASA, the White House, the State Department in the past. Could you take just a moment and just help us, walk us through your journey that brought you here today?
Well, it's a circuitous journey, that's for sure.
They
Originally from New
usually
York.
are.
Yes. Originally from New York, quite an urban chap. And my undergrad was from New York University, combination of computer science and media technology, which is a precursor for video game design and development. And I was really passionate about cartridge games back then, the Atari especially, but also getting kind of my teeth cut on the early software in the Mac and things like this. And I moved out to Northern California, to Marin County, to start a video game software company, a special effects software company with some friends. We were working with George Lucas from Industrial Light and Magic, Star Wars fame. And we were doing all kinds of interesting tools and technologies for the transition of optical to digital effects for motion pictures and TV and movie and commercials. And then as well, we were doing video game design and point systems and different kinds of interesting pieces of the puzzle for Atari, Sega, Nintendo, and then the emerging CD-ROM market that was coming out, and doing also interesting things with interactive video. But what really happened to me, I think that's very important, is that I was north of Silicon Valley, north of the Golden Gate Bridge, in a sort of semi-rural area that is called Western Marin. And even the town that I was in, people were riding horses into town to get their morning latte. So it was quite a culture shock, to go from New York City to a place where people actually used hitching posts for horses to get their morning coffee. But I was starting to befriend these small plot family farmers and be invited to these farm to table dinners and meals. And I was just so inspired by the flavors and by the people and the communication and this feeling overall that I was getting of happiness and health and connectedness. And that's really what started me on this journey of doing case study research of organic, biodynamic, small plot family farms, and this wonderful world of what's called eco-villages and intentional communities, co-housing, co-living, most of which are around food and organic farms and nature, right? And especially these eco-villages, which were really designed around what's called permaculture, and the fact that these communities were really considering everything in their footprint relevant to circularity and whole system design thinking. And that was the rabbit hole really was Rudolf Steiner, Buckminster Fuller, this gentleman, Bill Mollison, on the topic of permaculture. So the sort of early 20th century, mid 20th century minds on whole system, resource-driven design thinking. And that inspired me to, when I came to Stanford in 2012, armed with a primary thesis of could we create a software relationship to the natural world? And that's where this whole research bed started back in 2012. And so this storyline continues till today.
Well, I gotta say, if you open with video games, GPUs, and George Lucas, you starting strong. You caught the audience right there. What strikes me and I've heard this from a number of people, but I think it resonates in your story, is it's this balance between high tech and the real, the real world as we say it. And we're very focused on bringing AI into the real world. I love the idea that maybe you're bringing AI into a better world. And I think that balance is key. You meet people who design autonomous cars, it's because they love the feeling of the wind rushing through their hair. They design, a number of high-tech systems, but it's all rooted in the world around them. Is it fair to say that sort of you're striking that balance between high tech and a better place to be?
I mean, absolutely. My whole life has been technology as a means to an end, right? So how do we how do we look at where we are as a species and being in partnership with technology that
Hmm.
brings us to a more flourishing place? And that's been, the basis of my research and my background all these years, which is to find the rootedness and the commonality and what levels the playing field between people, and that's nature, and in many ways it's food. I like to say many ways that my research was driven by my stomach, because I travel around the world and and eat these delicious meals and meet these amazing people. You don't have to speak the same language. You just sit at a table, and the aromas and the flavors and the recipes tell stories,
Hmm.
and that's about ancestry, and that's about journeys, and it can bring people to tears, and it brings people to joy and laughter, and it's also the bioavailability, we would argue, of the nutrition that's being grown right by where you're sitting, and the access and the agency of people being able to connect with that. So yes, it's about tech as a bridge to improving those things.
So I love that. It's we can use the most advanced tech while staying rooted, no pun intended, in the real world. And we've spent a lot of time here at the foundation talking about bringing AI into the real world. I think you've got a fantastic and really fascinating vision about bringing AI to make a better world. Could you talk to us a little bit about the Village OS?
Yeah, sure. So we started this research back at Stanford in 2012, as I mentioned. Part I self-funded off campus, which
Hmm.
was two different research beds we were working on. One was in a small backyard context in East Palo Alto, which is right across the highway from Stanford. And the other was actually a small farm up in San Anselmo, California, up in Western Marin, which was
Hmm.
my old turf, and doing a bunch of different interesting experiments with farming, of aquaponic systems, of cultivars, and unification, integration of solar, wind, biomass, compost, anaerobic digestion, vermiculture.
Hmm.
So all these different systems that were in relationship and symbiosis with each other. And how could we sense? How could we, gather data and understand those things at least? So the first part of the research was about that. And then in 2016, we decided to create a spin-off company, and we founded the company in the Netherlands in 2016 to try to take this idea to the operational level. Could we actually build a community somewhere, let's say half hour from Amsterdam and in the Netherlands, and try to see how the operational models will work? And this is some of again, the early research for an operating system, right, of physical things in place.
Hmm.
Uh, and then, we suffered the slings and arrows of the typical real estate developer or speculating real estate developer, which was, just being inundated with all of these costs associated with planning, architectural design, and town planning, different kinds of surveys and data that we would have to get, and all of that, also having to deal with the communication with local authorities and local communities. And that was really what spurred the inversion to the sort of generative AI side of the design portion of the VillageOS. And so we've been working on that now for the last number of years to look at, first and foremost, the design side. What is the land capable of? And inverting that to, the typical design process from architecture, but to look at what the land is capable of from a natural resource flow and capacity perspective, and then bringing all of that into the frame where it can infer what is the most logical amount of human, animal, plant habitation for this parcel. So it really turns everything, on its side, inside out, in the right way. And that's what we've been working on. Yeah.
That's fantastic. What strikes me is most of the conversations you have with founders and, early days, there's always a creative solution. In your case, you self-funded, built your own farm. We've heard stories in the early days of some companies building servers out of Lego blocks because they had to come up with a creative way to do it, or posing as their own photographers to get the photos for the site. Founders always find a way. But the thing that strikes me is they find a way, but they still take signal to adapt. And this is that adaptation you're talking about with shifting to generative AI. Do you have some materials you can show us today that help us sort of get into that a little more?
Yeah, let me share a screen here and get into that. So let me just go through a couple of small questionnaires here that your software wants me to deal with.
Yes, yes. I'm sure you're carefully reading those terms of service like we all do.
Exactly, all the way to the end. So this is the VillageOS software demo that we have going. This is one of the contexts that we've been working on. It is extreme arid, as you can see. It's Saudi Arabia, just on the urban edge of Riyadh. It's kind of a sweet spot for us, by the way, is looking at life at the urban edge. The first thing you'll note is we load up the cadastral parcel boundary data. And then what we've been building out is an open API, application program interface, to aggregate everything in the known universe relative to this place and relative to places around the world. The idea is not only topography and protected habitat, but ground temperature, air temperature. We look at sky coverage, illumination range, daylit hours for solar arrays, solar panel placement, wind speed, wind direction. You see everything again is annualized historical data, not only for local residential wind turbines, but also for comfort. How do we design for comfort, right? And precipitation, when it does rain, how do we channel that water? This is classic permaculture design. Channel the water back through aquifers, cisterns. Every drop is precious. Soil mapping, wildlife corridors, traffic patterns, property values, demographics, cultural aspects, really, really important. Indigenous wisdom. Gosh, I mean, there's so much to learn, and having a platform, an ecosystem. Now, akin to my game design background, of course, we like to bring then the land and extrude it and bring it into this 3D game engine. And so we can see where we are relative to place, relative to Riyadh. And most importantly, we start with the contour map, because it's very important for us to look at the sort of triangulation, if you will, between contour, geospatial data, and climate weather data. This starts to bring some really interesting discussions and ideas for modeling. We start with fluid dynamics. Okay, we start with hydrology. So where would be the logical placement for water reservoirs, for aquaculture, for fish ponds, for digesting effluent through what's called living machines, but also what are the predicted days of resiliency based on the time of the year for these water bodies, which is really critically important for planning. But this is also a really interesting place to connect with small and large language models and foundation models. And imagine, if you will, kind of this ChatGPT dialogue with the land itself, where we can begin to explore and expose, what the land wants, what the land is capable of, and it really opens up a lot of very interesting conversations about nature and our relationship with nature for these systems and services. But then it can also, and I think this is really interesting, for systems and services specifically, like related to each of these topics, like in this case, water. What are the best kind of water pump systems? Where would be the best placement for water purification and digestion? But also, what are the best companies with products and services and local installers where they can actually upload and simulate and model their systems using this technology, using the VillageOS, but also then it allows them to essentially be part of the bid for the RFP process as these communities are being designed and imagined. We then go, after looking at the topo map and hydrology and fluid dynamics, the topic that's near and dear to my heart, which is food and soil profiles. Now, people have to understand that our health on Earth is related specifically to that 10 to 12 inches of topsoil. And when that topsoil is healthy, P.S., we're healthy, right? And so we've seen, even in the most arid conditions around the world and through our research, that we can actually restore soil profiles by layering biomass, a certain amount of animal waste, other kinds of organic fertilizer inputs. And you can start to see, we get this beginning kind of this golden ratio of productive open space to where we can start to imagine the built environment. And this soil, by the way, this profile can be farmable even within the first year of effort, because it doesn't take that long, after, let's say, the rainy season happens, that certain kind of amendments start to really take hold. And so that, in addition to controlled environment, greenhouses and farming, we can really get a mix of high protein cultivars, small animal protein, chicken, egg, turkey, other kinds of light dairy animals, goat, sheep, a few cows maybe wandering around for biodynamic purposes, aerating the soil, their fertilizer, etc. And also aquaponic systems for diverse fish protein, freshwater shrimp, crawfish, different kinds of freshwater fish species. In any case, once we start to get the snapshot of sustenance, if you will, what the land is capable of, we can start to do this little sort of Sim City-like modeling, right? And so here, the first thing we look at, this part of the world especially, is the placement of mosque for spiritual centers and being in walkable distance to the district areas. We then look at where we would put first responders, where we would have certain kinds of kind of education, other sports and commercial spaces, hotel. We would then also look at, for instance, where we predict the metro line would connect potentially from Riyadh itself. And then we can start to explore some of the exciting aspects of the kinds of different housing typologies based on the demographic data. And this starts to get really interesting because we can be modeling this. And as you see, as we're toggling the different kinds of housing typologies, apartments, townhouses, single-family homes, we're getting real-time per square meter feasibility and cost, which can then also then lead to real-time rate of return. What's particularly interesting and exciting is once we start to get to the demand side of this beautiful diorama, this immersive diorama, that we can then start to say, okay, if there's, let's say, somewhere between 12 to 1,300 families plus school, commercial spaces, etc., what do we need to empower this community in terms of renewable energy sources, right? So we would really look at, okay, what would be the logical number of effective solar arrays? In this case, again, we look at what's called agrivoltaics, so that even under the solar panels, we can be growing shade crops and light grazing animals, but also the combination of residential scale, wind turbines, biomass, biogas. We turn human animal food waste into energy, into heating, into cooling, into water purification. In other words, waste at the neighborhood scale is an asset class, right? And actually brings tremendous value to the community itself. Of course, at the district scale, it's huge amount of pathogens and requires lots of energy to mitigate. But this also speaks to a really important aspect of what we're doing here with the software, right? Is we're creating levels of security, food security, water security, energy security, waste to resource management security, and all of these things in the aggregate create healthier, safer, more beautiful, flourishing communities to live in. In other words, these communities, once designed, and I'll show you this sort of visceral experiences, the output into AR, VR, XR, right? That we can really imagine how these communities will improve over time, that the nature itself is what is improving the communities. In other words, abundant flourish. But we can also show that the extreme weather conditions, like what it's like when it does rain, how do we deal with the flooding, the puddling, how do we channel water back through aquifers, cisterns, if there's windstorms, sandstorms. But we can then take that back to our diorama, if you will, and there's a positive feedback loop in the design. One of the other really cool parts about the VillageOS software, and that we're continuing to work on and develop, is the ESG, SDG, carbon market sequestration modeling, which will allow us to be predictive. What will this community look like at groundbreaking? What will it look like 5, 10, 50, 100 years later, in terms of delivering all of these kinds of social, economic, carbon sequestration models. This then becomes an amazing side panel for sovereign wealth, pension fund, institutional funds that can look through kind of a back panel, if you will, of our software and look at projects that are being designed around the world that could actually benefit from their kind of larger finance coming in. So private equity, mezzanine finance that support the right kind of residential developments. We can also show the neighbors how these communities that are built next to them with the VillageOS software improve their property values, right? Also, that they become really an oasis, that when their district utilities have an interruption or failure, or their food matrices or other aspects of their daily lives are maybe compromised, that they can come to these flourishing communities and grab a meal, catch a cultural event, charge their devices, be really safe and safer. So there are long-term aspects and benefits to the design of these kinds of communities. And this is germane to the conversation today, because once the VillageOS software on the design side has sort of delivered a plan and the community can start to break ground and build these neighborhoods, the software will map an edge AI, tiny ML, small language model, essentially digital mycelial network, decentralized AI for actually operating the neighborhood with both human and then eventually small to larger robotic interventions. And so really the idea of the software is bifurcated. There's the design side, which you're seeing here, and then there's going to be the operational side, which is really about low power neighborhood intelligence, AI, that is decoupled from the cloud and from big data centers. So it's energy efficient. But most importantly, it is resilient because it is capable with very low latency of making decisions that can impact the improvement, mitigation of risk. And again, how do we look at predicting future systems and services in kind of like a digital twin like modeling that is perpetual, that is continuous. And that's where I think really the exciting part of Edge AI really fits in. So yeah, I mean, I'm also at Stanford. I've moved from mechanical engineering, which is the birth of this initiative at the Center for Design Research. And I've been in the School of Medicine now since 2017 in the Center for Compassion, Altruism, Research, and Education, because the key tenet really is how we live and where we live that reduce amygdala response and cortisol release. Those are the stress hormones, right? So if we're living really in access and agency with where our natural resources are being derived from, and we have sort of traffic-free communities where kids can play and elders can stroll, and we have spirituality and connectivity to ourselves and our community, these are all markers for happy longevity and reducers of burdens on governments, local, regional, national. Also, you can imagine that each one of these beautiful, flourishing communities that we design and implement around the world, that each one of these reduces burdens on local, regional supply chains, right? On food security, water security, energy security. And moreover, that if we can build enough of them around the world, we can start to stem climate migration. We can start to deal with really handling refugee crisis. There's a simpler path, actually, leveraging nature and the natural world. And that's everything that we're working on with everything that we do at Stanford and with our VillageOS software. So I'll stop the share there and happy to answer any questions you might have. Sorry, I can't hear you. I think you might be muted, Ed.
I have to do that once a day, just out of good habit. Do you mind leaving that up? I think it's a really interesting visualization while we chat.
Sure, I have to reopen it again. So sorry, I closed
no worries.
it.
No worries. So you covered a lot of ground there, and there's a few things I want to go back and touch on briefly, and I know we'll probably get some questions from the audience as well. First, I do want to recognize that while we spend a lot of time talking about systems thinking, and you have an incredible amount of data that you're pulling in together, I noticed that the first thing you talked about once you had that were these community and spiritual needs of the community and the transportation needs. It would have been so easy to immediately go into rainfall or productive soil depth or something else. It's interesting that when you up level into that systems level, you make sure that you're capturing some of the largest drivers like that. And I thought that was fascinating.
I mean, from our perspective, it is it's really trying to tell a very comprehensive story, but rapidly, right? That we can look at all the different facets that are typically holding up planning decisions and slowing the process down, and try to find efficiencies with that. So that's one of the first, I think, key parts of AI with us. And then going forward, it's okay, what are the interrelationships between previously siloed neighborhood infrastructure systems? I think that's one of the most exciting parts about what we're on about here, is how to really create sentience at the neighborhood scale, and that these systems can learn from each other, improve or mitigate against risk. And I think that's pretty critically important overall.
So you touched on something really interesting there. We were talking about the system as a whole and learning its sentience itself. It strikes me how complex these systems are, but also when you wrap them in a semi-familiar view, like a quasi-open world that we've all played in video games and things like that, how much data and how much integrated information you can take in. So that style of visualization feels very familiar, but also very applicable. I can see how this works very well for new de novo development, but I think you also mentioned it may also be better for, say, brownfield visualization, which is, okay, there's already things there, but what could it be? Is that a fair assessment?
Yeah, we start with the green field at the urban edge, and I'll tell you why. There's this wonderful Google Earth plugin, maybe you've seen it, where you can pick any city pretty much around the world, and there's a slider bar that allows you to go back 30 years.
Ah.
Okay, and when you slide back 30 years, you see what used to be farmland, and then when you slide forward, it's been taken over by suburban sprawl, by urban sprawl, and it's paving over that farmland and that arable land. So what we're trying to do really is get to that near suburban areas and eventually more peri-urban and even rural areas to rejuvenate them and create these maps of self-sufficient, capable communities that can be there to create a steam valve in many ways from the urban areas. That's where we want to start with. Also, to be perfectly honest, greenfield areas are a lot easier to design with implementing new technologies for edge AI and for robotic interventions and different kinds of things. Because trying to retrofit from an old infrastructure coupled with new infrastructure, there's lots of complexity, more complexity there. So we're not against going back to urban areas to look for interstitial spaces that we can do overlays with. For instance, block by block, building by building, how can you bring those areas to more kind of regenerative resiliency? But the key thing for us is to start with, especially we think that the rural areas around the world, rural India, sub-Saharan Africa, across ASEAN, MENA, that these are places where they've been abandoned in many ways, but we can start to rejuvenate them and start to draw the rings of poverty, maybe back out from the urban areas, back to their native villages, and to stem climate migration from the rural areas to the urban. These actually create these lily pads of productive places that start to, reboot, if you will, our species in relationship to Earth and nature. That's our primary goal.
Yeah, I love the idea of it's not just AI in the real world, it's AI for a better world. But you're highlighting a canonical founder problem. Founders see the world, they see something better they can introduce to it, but then part of the challenge is introducing that into a world that isn't built for it. So, the idea that you might start in certain areas versus others to allow you to gain those demonstrations, those pilots, and move forward is really interesting. We do have some questions coming in from the audience. Can you see those, James, or do you want me to narrate them for you?
If you would narrate, that would be great, so I don't have to go through them.
We have a question from someone who would like to ask, is this software that can be integrated locally on hardware or an embedded system for business-to-business use?
Sorry, can you just repeat the question one more time?
Sure. It sounds like we have someone would like to test the software or apply the software in some other applications. Is it something that they can, go to a link to, integrate locally, and apply in business-to-business visualizations?
Yeah. So where we are right now, we're working on an open source API that will allow everyone around the world to engage with the platform. And we're really excited about releasing that. It's not there yet, but we're working on that. And the software itself is something that's still being developed, in all honesty. And we have a very elegant, agnostic middle layer software that's the framework of the VillageOS, which is also abstract, capable of ingesting almost everything that we're able to aggregate data-wise. And the same thing now with where we're going with the visualizations and these emerging platforms for being able to bring this in the most democratized way imaginable. Our goal really is like the aging farmer, let's say, around the world. They're not getting economic value from monoculture and farming anymore. Their kids don't want to farm. Their grandkids don't want to farm. The land is valuable, so they're asset rich, but they're cash poor. And they want to, at the same time, keep a certain farming heritage and legacy tradition for that land. And the same thing with the local regional governments. They don't want to pave over and compromise arable land. They want to have a balance. So this is really where we're going with the technology. But to answer the question, quite specifically, not yet. Soon.
Well, let me fold in another question that we have here. Is there a link that people can go to stay apprised of the project? We have a wonderful community around the world of, open source contributors, excellent engineers, excellent scientists. How do they, as you progress, stay in touch and when things are ready for availability, be in line to pick up these assets?
Sure. So a few things is regenvillages.com. It's the name of our website. That's it's still a bit cryptic, but there's ways to reach out to us and sign up as well to a mailing list.
Mhm.
We're still pretty quiet, to be honest, because we're still pretty heads down working on things. But I would say that, and also reaching out to me through my Stanford email, which I'm happy to put into chat, and people can email me directly because I love speaking to people from all around the world, and especially those folks who have a technical background and are super interested in wanting to make a difference with their technical background. And we're a small mission driven team on the Regen Villages and the VillageOS side. We have a wonderful group of people, of researchers and scientists and faculty at Stanford. We're so blessed to be nested at Stanford University with this work, and really excited about what's coming. We're just yesterday proposed to be part of the Door School of Sustainability at Stanford and their Planetary Intelligence Accelerator, which is so exciting. So John Doerr, if you're familiar with the venture capitalist, he put some money into Stanford 3-4 years ago to create a whole new school specifically on sustainability. And what's magical about the Doerr School of Sustainability is the fact that it is really celebrating interdisciplinary capstone work and bringing all different kinds of minds and people together. So yeah, really happy to connect with people. I'll also put the website in the chat as well.
That sounds great. We have a very, very talented, very diverse global community, as I mentioned, of engineers, scientists, business leaders. Are there certain areas where you would love to see rapid advancement? For example, model development, hybrid architectures, hardware. Are there any particular areas that would be uniquely useful for you in this effort?
Well, yeah, I mean, everything we've done so far you can see, has been pretty predictive, right? So we
Mhm.
started this research back in 2012, really feeling in our DNA that at some point within the next decade, that AI, ML, sensing, robotics would really be coming to the fore, which is what's happening now.
Mhm.
So where are we now that we can look forward to the next 10 years? What's going to be happening 10 years from now? And so in that regard, we're really interested in let's say the future of sensing, like on things like called memristors, right? These sort of biological organic sensors that are not only able to sense and compute and have a certain amount of memory in themselves, but that the biological nature of the sensor itself is capable of, in the moment, doing something that would either mitigate or improve, whatever the circumstances. So there's a whole new era of things coming that we're really interested in. The current, I would say, effort is we're always looking for people who have a whole system design mindset, which is really challenging because people focus, obviously education is focused on typical siloed approaches to things. But we're really trying to find folks who are looking for or discovering the relationships between things. And that's really the kernel of our VillageOS software.
Got it. Got it. Okay. There is a really interesting, another new question around balancing small language models and large language models. Now, obviously, there's always a trade-off between constraints of remaining in a limited environment versus driving inferences in on-prem or to the cloud. So maybe this is a question about hybrid infrastructure. Are you thinking of these lily pads that you called earlier as completely autonomous nodes, or do these nodes behave autonomously but have some interaction with each other? What's your thoughts around hybrid work?
Um, I like to talk about the Amish.
Okay.
When the Amish in Pennsylvania, when the power goes out for the Amish, then for them it's Tuesday. Like, in other words, it doesn't matter, right? So in other words, how do we get to that level of resiliency? And that's our goal, right? Eventually, is that these
Mhm.
are autonomous in their own decision making intelligence at the neighborhood scale. So I would say that perhaps a small data center, if you will, super energy efficient at the edge, is a lot more compelling for us than the giant data centers that we would have um, to link to. Initially, we will have a thin pipe to the cloud and be able to upload, highly anonymized and encrypted and compressed data that can then be understood, especially with the relationship with different communities, but in similar climate zones. For instance,
Mm.
like we were modeling something in Nevada that's very similar maybe to some aspect of things we're doing in Riyadh. There's some similarities there that we can draw on. Not one
Mhm.
to one all the time, but some similarities in terms of the arid nature of things, or across the Nordics, for instance, that one community can be speaking with another, and learning from each other, improving, mitigating against risk, etc. So I think all of these things in terms of tiny ML on the sensing and operational and the physical, to to the more semantic on the small language model, for those, like, processing ideas about what's happening, and then really communicating that at the edge to be able to actuate the robotic interventions eventually. So
Yeah.
we're really staying. I think we're really trying to imagine, again, predicting how can we get to that ultimate resiliency, if that makes
Got it.
sense.
Got it. Well, what I like about what I'm hearing from you is an intentionality. So
Mhm.
if there are certain tasks or inferences or actions that need to be taken at the limited edge, the smart edge, or on-prem, they happen there. There may be moments when sharing information across nodes makes sense. Your example of Nevada to Riyadh, I was thinking, distal nodes and flooding to more proximal nodes. But the intentionality of you don't automatically ship everything to the cloud, but we do locally what needs to be done locally, and we have cloud interaction when it makes sense, when there
Mhm.
is, asymmetric value to doing that. Is that a fair assessment?
Yeah, I would say so. I think we everything is going to be a bit of a balancing act.
Yeah.
That's what we have to really. Let's really have to look at things. What we're looking at here, in many ways, is a living organism. A neighborhood, a township, is a living organism,
Hmm.
and 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 currently the way they're architected and designed and planned is is really sort of anathema to that, and the systems are myopic and siloed. And what we want to say is, hey, let's look at the open space. What is it capable of? And then how can we create systems and services that are in communication with each other and have compassion for each other? In other words, there's a certain amount of empathy between a energy system microgrid and a water system and waste system and the food matrices, etc. That they're in constant dialogue with each other,
Hmm.
also assessing their own needs. And I think that's really the critical part. Like for instance, when we eat something or drink something, we don't have to. Our brain doesn't have to tell our stomach. Like we don't have to ourselves be involved in that process, right? We have a natural system that's dealing with all of those things. And our bodies are an example of that symbiosis. So, and nature, of course, is the greatest biomimetic reference that we can get for
Hmm.
these systems. Edge AI, tiny ML, small language models, from my perspective, is the most exciting part of AI that I've seen, right?
Hmm.
Because it completely resembles mycelial networks. These
Hmm.
large fungal organisms, they don't have a central brain. They're giant organisms that can span 30, 40 radial kilometers. But they're these wonderful brokers, inoculating themselves into the root system of trees, plants, bushes at vast distances. And it's a have-need network. So they're communicating what the plants want, and then a conveyor belt of carbon, phosphorus, minerals, sugars, even water, right? It's pretty amazing. And they're also self-healing and capable of constantly learning. That's what I love. So it's an organism that's in competition with itself in a way, but in a friendly competition, and it's always searching and always exploring. And that's where I really feel that edge AI, tiny and non-small language models, that's the evolution that I would love to see happen.
Interesting. I love it that you're not only maintaining a systems perspective, but you're sort of changing the definition of resilience. So we have lots of conversations about this is a resilient installation. What they're really talking about is a lights off data center. It's resilient. It can adapt to changes. You seem to be tying the resilience of the community and the humans within the community to its fundamental infrastructure. And that's a big challenge, but it feels like a worthy challenge. So it doesn't matter if the machines keep working if the humans can't function and thrive. So resilience being defined as a balance of human level, community level, and infrastructure level investments is a fascinating conversation. Am I getting that right?
That is correct. And again, the key is these longitudinal studies that we look forward to on improved health and well-being and
Hmm.
nation state security eventually. These should really be topics of government right now. And
Hmm.
I'll say it very importantly so that because of AI and robotics and sensing, we're going to see increasing unemployment,
Hmm.
and that is going to be a bit of a shock. I'd say a tremendous shock, unless we can start to create communities and infrastructure that stand up a certain amount of people's daily human needs, right? If your neighborhood, for instance, can stand up a certain amount of your daily nutritional needs, hydration, your power, being able to digest and convert your waste into resources that are valuable, an asset class. You have smart mobility and mobility on demand as a solution. And then there's kind of a sort of a reduced delta layer of universal basic income, which is predicted at this point. It's got to happen.
Hmm.
Then all of a sudden, I feel like we have a fighting chance to create new economic models, to shift the dialogue from work and jobs as a metric to self-worth, where people feel like they wake up in the morning, they have something that's interesting that they want to do, something creative, something that they feel empowered to do, and that they're okay, that they are okay, their families are okay, their kids are okay, their elders are okay, pets are okay. They're living in places that are safe and safer. Gosh, that's the role of technology. That's really where we need to be focusing things.
Hmm. Hmm. I think it's a compelling vision, and I'm already seeing. I'm going to encourage you to, whenever you're ready, provide more links on the regenvillages.com site. Some of the audience are already talking about new scenarios: drones to harvest biosensors, potential for fuzzy logic to provide contributions as well. I feel like you've got a great community here who'd love to engage and love to contribute. To your last point, I know, and actually building on that community contributions, it is interesting that a lot of the early conversations around the applications of AI and new technologies has been to mitigate. So specifically, dull, dirty, and dangerous jobs to be replaced. And I had a friend who used to design drones to go fly up in mountains and check power lines because if you send humans up there, they're really putting themselves at risk. That's a great conversation. I feel like you're raising the bar and saying actually it's more than just mitigation, it's augmentation. So how do you improve life? Is that the direction you're going?
Absolutely. And look, to take a step back, to many years ago when I started, this journey, because I was fortunate enough to meet these small plot family farmers and these eco villages and travel around the world and eat these delicious meals and break bread with people, from all different cultures, is that when you go to visit an eco village, there's something really powerful that happens. You're going to a community that was intentionally designed, that is car free. Typically, they have kind of a mobility at the edge. Then you either walk in, bike in, or maybe a small golf cart that takes you into the community itself. And the first thing you'll notice is pollinators. There's hummingbirds, there's butterflies, there's bees. You hear them, you feel them. The subdivision across the street, it's dead, nothing going on. These eco villages, something's going on there. At night, the owls, the bats, okay? They themselves are bringing new life every day to this enclave, to these communities. You see people, children, elderly, people with babies, all living together in these communities. You go to the community center, it's one of my favorite parts. You go to the community center, it's usually a larger house or a building that's the central meeting place. And there's a message board, birth celebrations, life celebrations, birthdays, graduations, retirement, hospice care, and death notices. Because there's a circle of life and a story arc that people are not afraid to be living in these communities and in multi-generational ways and really sharing each other's lives together. It's a really important part of feeling healthy and connected. How do we get that? How do we get technology to enable those kinds of things to happen for us? And that's how we used to live on Earth, by the way. We used to live with our full menu, pretty much diet at our doorstep, or pretty close within the village piazza. We had engagement with each other and connectivity with each other. How do we do that? How do we get to those places that can be made better over time? And that's what I'm talking about, because each one of those eco villages, interestingly enough, the microclimate over them is different. They get a little bit more moisture. They're giving off a little bit more humidity, and the soil is better. Everything is improved. That's really where we want to see things go in the future.
Right. So we're already seeing, I mean, and we love our global community. We're already talking about fuzzy logic and reinforcement learning and supervised fine tuning. Sounds like you'll also need, input from sociologists, psychologists, etc. This is going to be a multidisciplinary conversation. We only have a few minutes left. I do want to ask a core question though. As a serial entrepreneur, as a founder, as someone who advises, up to in the past, the White House, etc. What advice would you give our community when you have such a bold vision for the future and the world isn't built for that right now? How do you get past the initial no's, the initial friction, the initial that's never going to work and keep going? Or should you
Well,
keep going?
I always keep going. There's no choice, right? You have to have optimism. You have to have hope. That's one thing that I find that entrepreneurs, successful entrepreneurs especially, have, is that they have a little bit of a crocodile skin in some ways from the rejections, but also internally that they have infinite optimism, that ideas are worthwhile and that they're important. And I'd say that's one of the critical things. Creativity in imagination, as Einstein would say, is much more important than knowledge. That you need to find ways to express that creativity, because those are the places where the gaps are in technology. And empathy and compassion and finding, I really feel that we need to find solutions for all of us and really be working on those things. That's what brings me joy and value every day. And talking to people from all around the world and meeting people and understanding the commonality we share. And that's why I'm so also grateful to be part of this C-Care Center at Stanford, because it really is all about design empathy and thoughtfulness towards others. And that by being in that way and living in gratitude as well, that it improves our health, it improves our well-being, and it gives us this opportunity to see a brighter future. So yeah, I would really hope that people are optimistic and hopeful about their capabilities to make the world a better place. And that's where I think if that's the focus, then you can never really go wrong. That's my opinion.
Yeah, that's fantastic. I think we have time for one more. Let's say you're a student, you're coming out of undergraduate, graduate, you're just about to start your career, and you can see the entire world is changing, right? And the old expression is change is challenging, but certainty is absurd. So we have to understand that the world's going to changing. What's the one most crucial bit of advice you would give that person who's starting their career and moving into this new world?
I would say to celebrate whole system design thinking, to go out into the world and to get your hands dirty with some farming, some agriculture, some cooking, some understanding of where things come from and where they go, right? Those are really important aspects to that. Everything we're doing is to collapse the distance from where things are produced to where they're consumed. So how do you live in that way? Also skills, electrical, plumbing, carpentry, these are really important skills that enable people to do things for themselves if they need to. And that's something we really need to prepare ourselves for, because to be perfectly honest, we predict more and more interruptions, more and more disruptions. And that's why decentralizing is the most important thing we can do. And that's where we have our own skills and our own safety and our own security that is then contributing to community security and safety. So those are the things that I think would be interesting to think about for any student at this point. That's my personal feeling.
That's perfect. And last question, have you been back to Marin? Are friends still riding their horses to get coffee in the morning?
There's not so much horse riding into town as there was in the late 80s, early 90s, unfortunately. The hitching posts are still there. I do get up to Marin, and not as much as I would like to these days, because Stanford is, now with traffic and everything, is about an hour and a half maybe away. But I do get up, and it really is grounding for me all the time. Whenever I go into nature, whether I go to the ocean, whether I go to the forest, whether I go to the mountains, I'm always reminded about the most important parts of life, which is that we are this miracle species that has an opportunity to make life better for others. And that makes our lives better. So that's what I'm reminded by every time I'm in nature.
That's fantastic. Well, we started this conversation with GPUs, video games, George Lucas, and coffee, and we're ending with a fantastic call to action. Our thanks to James. It's outstanding to have you here. Thank you so much. I hope everyone can reach out to you at the regenvillages.com site, the Stanford site, or LinkedIn. Is that okay, James?
Please, yeah, I put it into chat, but I wasn't sure if the chat was just for the three of us or if there was with public. But great, I'm really, really blessed to be here. I'm grateful for the questions, those people who caught this live, And please be in touch. We need people. We need your help. This is not a one person thing. This is a grand vision that we hope to really bring out.
Yes, and thank you to our global community. You're the reason we can bring AI to the real world and, in to James's case, AI to a better world. So thank you to everyone and have a great day.